So this is the second video done by Mr. Smith for today. Um, so we're going to talk about testing equivalence and solving proportions. All right. So by testing equivalence, we're finding out, are two fractions actually equivalent? And so there's lots of ways. We've covered a few of them already today, or over the past few weeks in class. And then we're going to do some solving proportions, and we're going to get into why cross multiplying works. Okay. And the beauty and power of cross multiplying is that it can work for many things. In fact, you will be cross multiplying from now until grade 12. And if you take mathematics beyond, you'll probably be cross multiplying into college and university. So let's get into it. Let's talk about testing equivalence. All right. I say here, I make a claim, so we'll just call this example number 1. Okay. So 1/2 is equal to 2/3. Well, is that true? No, I think some of you already know. First of all, how do you know? Well, I think a lot of you who know your benchmarks pretty good are saying 50%. 1/2 is equal to 50%. 2/3 is equal to 66%. Okay? And so that is not equal. I should really put a line through that and say, these are not equal. All right? You also know that they're not equal because if you were to convert them to a decimal, which is really the step you need to jump to a percent, unless, of course, you've memorized it, is the fractions here convert to a decimal of 0.5. Sorry, I was thinking there, guys. And this is just 0.666 repeated. Okay, that goes on forever. Another way of writing that is to use the fraction bar or the bar above and just say this 6 repeats forever. Anyways, we know that those decimals aren't equivalent, right? The fractions aren't equivalent. The percents are not equivalent. The decimals aren't equivalent. There's another way you could check. You could check through cross multiplying, okay? And so this kind of gets into why cross multiplying works. Both for, you could use cross multiplying for a number of things. Number 1, you could use it to prove equivalence. Number 2, you could use it to prove that fractions aren't equivalent. Number 3, you can prove, and this is how we'll end the lesson, this video, you can use cross multiplying to solve for unknowns. But let's just look at this from a cross multiplying, okay? Let's go back and use blue. Okay, so the original thing said 1/2 is equal to 2/3. Okay, well, I know that this doesn't work because if we actually cross multiply, okay, and what we're saying is 1 times 3 is supposed to somehow equal, okay, switch the colors, let's go with pink. All right, and you're supposed to be able to take one fraction's denominator and multiply it by the other fraction's numerator, and you're supposed to have the same number come out, okay? And look what happens here. What's 1 times 3? Well, 1 times 3 is 3. 2 times 2 is 4. Well, that's not equivalent. So cross multiplying can provide you what we call, just a little detective work here, we can use cross multiplying to provide you proof. Okay? So let's go to example 2. Now, some of you are just going to use factors to solve for this. In other words, those of you who are really good at your times tables might say, Mr. Smith, I know that to go from 7 to 49 on my times table, I have to multiply by 7. Okay? So in other words, maybe you don't know what the percentage is here, right? Maybe you don't know what percent this is. Maybe you don't know what the decimal is. Okay, well, that's fine. There's lots of ways to figure out, that's a letter M there, Mr. Smith. There's lots of ways to figure out whether two fractions are equivalent. The other one is to use like common factors. So if we multiply 7 times 7, we do get 49. If we multiply 3 times 7, we get 21. So yes, I know right now these are equivalent, okay? I know these are equivalent. Do you love how Mr. Smith can spell with his pen? Whew, I'm out of practice on this. I've got like a writing tablet here. Okay, but you can also cross multiply, okay? You can also cross multiply. So I don't know, I'm going to switch to purple here. Okay, let's see if we can prove it with cross multiplying. Okay, I'm just going to abbreviate that. So Cross multiplying says if we take 3 over 7, and that's supposed to equal 21 over 49. All right. Well, I'm going to go use my original butterfly colors. So on one hand, with the green, one fraction's numerator times the other fraction's denominator. So we take one fraction's numerator, the other fraction's denominator, and we take, oh, that's an ugly looking 3 there, Mr. Smith. 3 times 49 is equal to, and what did I use for the other butterfly? Pink? Okay, so that supposedly is equal to the other denominator times the other numerator, so 7 times 21. Well, you know, Mr. Smith, I like my mental math, so I'm reasonably good at it. Let's figure what this is. 7 times 20 would be 140, so one more 7. So this is 147, okay? This is 147, and if you don't believe what I did there, you could always work it out longhand, okay? 7 times 1 is 7, 7 times 2 is 14. And in fact, why don't we just hang on, write the bigger number first, Mr. Smith. Why don't we just do it longhand with 49 times 3, 9 times 3, 27. So far, so good. 3 times 4 is 12, plus 2 is 14. Okay, so cross multiplying also provided us proof, okay? So you can use cross multiplying to prove or disprove. Now the last one, I think maybe I regret I made it a little too easy. Again, I think some of you are looking at this. Oh, hang on a second. I erased something here. Hang on a second. That's supposed to be a 68. Okay, carry on. So some of you might realize, well, Mr. Smith, I'm going to inflate this fraction. I'm going to blow it up. I'm going to make it 4 times bigger. 4 times bigger. And so if I multiplied this 16 by 4, do I get 68? Well, I don't know. Let's figure this out. 16 times 4. That's equal to, let's see, 24, carry the 2. I already know there's a problem because the 1's digits don't match. 4 times 1 is 4, plus 2 is 6. So no, this is not a match. Now, the other way you might have known this is you could have done it through percents, right? You could have done it through decimals. Let's look at what a decimal is, okay? So I'm just going to pause it here and do decimals. Okay, so I've done some decimal work here, all right? 16, what I did first is I reduced or simplified these fractions. I said, I could reduce 16. If you can blow up fractions, if you can inflate them, and if you can make them bigger, this is like a balloon. You can also make them, you can shrink them. You can make them smaller. You can simplify, you can reduce. 16 divided by 4 is 4. 20 divided by 4 is 5. And I know that 4 out of 5 is 0.8. Now, if that makes you feel better, you can also write in 0.8. And if it really makes you feel better, you can write in the percent. It's 80%, okay? Now, over here, we have 68, and again, I reduced it by 4. I got 17 out of 20. I can't reduce that any further. But I do know that 17 divided by 20, that's what fractions is. Fractions is division. That's 0.84, or in other words, 84%. Okay, so right now, I really know that these two are not equivalent. However, I'll pause the video one more time, and I will show you how I can do this with cross multiplying, okay? Okay, so I set the cross multiplying, and by the way, did you notice something here? Look what I did. Instead of, I could do the butterfly this way, but look how big those numbers are, right? Those are pretty big numbers. So what I did was I used the simplified fractions. By the way, if they're the equivalent fractions, you can set them up. So yeah, my butterfly could have been 16 times 80, 20 times 68, but I'm going to get, wow, that's a ginormous number. Look what I did here by using the reduced fractions. Do you see why the reduced or simplified fraction form is so powerful? Because it's easier to work with. 4 times 20, 5 times 17. 80 equals 85. What? I don't think so. I do not think so. So in the end, so I'm going to get a big purple here, okay? What was equivalent, what wasn't? This was not. This was not, okay? And this was. All right? Okay, that's testing equivalence, grade 7s, and we're going to do one more video. I've decided to break these up into 2 separate videos.